It's that exciting time of year again. The start of a new school year brings with it fresh opportunities and the chance to inspire the next generation of environmental stewards. For those of you embarking on your first year teaching AP Environmental Science, a huge welcome. You're likely brimming with enthusiasm, perhaps a touch of nerves, and a whole lot of questions about where to begin. And for the seasoned APES veterans out there, you might be looking for innovative ways to reinvigorate your lessons and boost student success even further. Having spent 8 years in the APES classroom myself and another 5 years diving deep into student responses as an AP reader, I've seen a lot of what works and what doesn't. Regardless of how long you've been teaching APES, this guide to a successful year can help you start planning how to prepare your students for the exam and beyond. Before you dive deep into planning, you need to make sure you're familiar with the APES exam. Understanding its structure and expectation is a great foundation for your instructional design. The exam is divided into 2 main sections. Section 1 includes 80 multiple-choice questions that must be done in 90 minutes. This section is worth 60% of the score. Section 2 includes 3 open-ended free response questions, or FRQs, that are done in 70 minutes. These FRQs are worth 40% of the score. Knowing that breakdown, now let's look at the question type students will need to be familiar with. On both sections, the questions will test 7 skills, or science practices. The first science practice is concept explanation, which includes questions that test students' basic knowledge of the concepts covered throughout the year. Science practice 2 uses visual representations. Questions with this science practice will have an image, such as a map or a drawing like this soil texture triangle, that will need to be analyzed to answer the question. The third science practice is only found on the multiple choice section and is a text analysis, where students are given an article and have to answer questions based on that article. They may be asked questions like, what is the author's claim? What is the author's perspective? What assumptions can be made? And what evidence from the article supports a claim? The good news with Science Practice 3 is that students generally perform well on these questions. Over 90% of students answer them correctly. So, make sure to have students practice these using tips like read the questions you have to answer before reading the article, but you should not waste too much instructional time focusing on this practice unless your students struggle answering them. The fourth science practice is scientific experiments. These questions often provide data or information about an experiment. The questions will have students identify the hypothesis, scientific question, the independent and dependent variables, the control, confounding variables, and even how modifications to the experiment might impact the results. Science Practice 5 is data analysis, where data will be provided in a graph or table, and students will be expected to analyze trends in the data, relationships between variables, and draw conclusions from the data. The sixth science practice involves mathematical routines. This includes students calculating math problems and showing their work. And finally, Science Practice 7 is environmental solutions. Questions with this science practice will either provide an environmental problem or provide data that is linked to an environmental issue. Students will then be asked to describe the problem, provide a solution, describe advantages, disadvantages, or unintended consequences of a solution, or justify a solution with another advantage the solution provides. While all of these science practices are assessed throughout the multiple choice section, each free response question will assess specific science practices. The first free response question is designing an investigation. This will always include parts that test science practice 4, as well as potentially science practices 1, 2, 5, or 7. Free response question 2 analyzes an environmental problem and proposes a solution. This means that science practice 7 is always tested, as well as potentially science practices 1, 2, or 5. The third free response question is also analyzing an environmental problem and proposing a solution, but with calculations. So this question will always include science practices 6 and 7, as well as potentially science practice 1. Also, each of the free response questions have task verbs within the parts that are bolded. These task verbs are identify, describe, explain, calculate, make a claim, propose a solution, and justify. Understanding what is expected of students with each task verb will help students provide enough information to earn the points. For example, identify questions do not require elaboration, and students should not waste time writing more than one sentence. While explain questions should have at least 2 to 3 sentences to not only answer the question, but also elaborate with why or how that is the answer. Also, don't forget to account for the recent change to the exam as of this last year. The APES exam is now administered digitally using the Blue Book testing app. So, in addition to making sure students are familiar with the science practices and types of questions they will encounter, it's also important to have your students practice answering these questions digitally throughout the year. Scoring distributions can be helpful to show the difficulty of the exam and how students generally perform on average. This table shows the scoring distributions for the APES exam after the major rewrite in 2020. It's important to note that although a score of a 3 and up is considered a passing score, some universities only accept 4s and 5s. While it's hard to get a 5, shown by the lower percentages, a score of a 4 is more attainable. Also note that although only a little over half of the students who took the exam from 2021 to 2024 passed, the percentage who passed in 2025 significantly increased to 69%. This change happened because the cutoffs for a passing score were adjusted to better reflect the number of students who demonstrated the proficiencies required for college credit. This adjustment is expected to continue this school year and on. Now that we have a clear understanding of the expectations for the APES exam and how well students do on average, it's time to start planning your year. If you're relatively new to teaching APES, I would suggest you follow the order of the units given to you in the APES course exam description, or CED. You can find this document on the College Board website, and it provides you with every topic that needs to be covered throughout the school year. Besides just teaching these topics, what are some other ways you can set your students up for success? So let's explore some practical strategies you can use throughout the year to not only help your students master the content, but also develop the skills necessary to excel on test day. My first tip: embrace labs and hands-on activities. 25% of your instructional time should be dedicated to hands-on activities, including labs. Hands-on activities reinforce topics, increase student engagement, and provide opportunities to practice the types of questions found on the AP exam. While there are no required hands-on activities, College Board does provide 19 suggested labs you can use. There are also countless other activities that can be found online that don't require extensive lab setups if you have a limited budget. Some of the most engaging labs and activities that my students loved were the Tragedy of the Commons simulation, cookie mining lab, soil testing, and water quality testing. When selecting activities for the year, make sure to prioritize those that apply the concepts covered in class well and integrate free response style questions into the pre- and post-activity questions. This allows students to practice answering questions with task verbs, as well as incorporate science practice questions in a low-stakes environment. So, for example, before or after a lab, you could ask students science practice 4 questions, asking them to identify the control group in the experiment, or explain how the results in the experiment could be altered with a specific modification will really emphasize this skill. By embedding these question types into your labs and activities, students gain repeated exposure to the exam's demands without the pressure of a full-length free response. Students often solidify their understanding when they can articulate concepts and teach others. So, the second tip is to incorporate more activities where students have to learn information well enough to teach their peers about a topic or convince other students to understand a side of a topic. This can be done through presentations or debates. Although presentations take a lot of class time, they can be a good way to introduce multiple topics without using a lecture. For example, after covering the environmental problems associated with agriculture, assign each group a sustainable agricultural method to research and present how it mitigates the environmental problem. That way, you have not only covered each type of sustainable agricultural method, but you've also covered how they create solutions to modern agricultural problems in a more engaging way. Debates can also be a fun and engaging tool in APES. Debates work really well in this class because there are positives and negatives to every topic, whether you're discussing environmental, societal, or even human health impacts. There are many examples of debates that you can use in this class. Is paper or plastic better for the environment? Are wild caught fish or farmed fish better for the environment and human health? Do GMOs have more pros or cons for the environment? What's the best alternative energy source? Which industry has the largest environmental impact? Debates encourage critical thinking and the ability to consider multiple perspectives, which is valuable for analyzing environmental problems and proposing solutions. My third tip: integrate case studies. Case studies are powerful tools for making abstract environmental concepts more concrete and memorable for students. For instance, when teaching the Clean Water Act, don't just have students memorize that the Clean Water Act regulates only point sources of pollution into surface water. Instead, also tell the story of the Cuyahoga River fires in Ohio. Show the vivid images of the oil-slicked river on fire that galvanized public support and led to the passage of the Clean Water Act. This narrative makes the legislation far more impactful and easier for students to recall. While there are many case studies you can use throughout the year, here are some effective ones you can include. Love Canal to remember CERCLA and hazardous waste. The Dust Bowl to introduce sustainable agriculture. The Aral Sea disaster to discuss water diversion. The Yellowstone Wolf reintroduction to discuss the causes and solutions to trophic cascades. And the Three Gorges Dam to teach the impacts of hydroelectric dams on the environment. My fourth tip: be strategic with FRQ practice. While multiple choice questions account for a higher percentage of the exam, the free response questions are often way more challenging for students and require significant practice. While some teachers like to start practicing full-length FRQs from the beginning of the school year, I found that it's actually better for student confidence to hold off jumping into those full-length FRQs until students have learned enough content and are familiar with the expectations. So start small. As I mentioned earlier, begin by including FRQ-style questions into labs and activities, and grade the answers similar to how an AP reader would. For example, for the task verb calculate, students should get credit for showing the correct work and credit for the answer. For the task verb explain, make sure students understand that there has to be reasoning provided for how or why that's the answer to get credit. For the task verb propose a solution, only give credit to realistic solutions and provide feedback on why a solution might not be realistic. You can also break up full-length FRQs into smaller chunks and include them on tests and quizzes. So, instead of completing a full-length FRQ that might have more information than students have learned only a unit or two in, use only a part of an FRQ, like only Part A or Parts A and B. Once you feel confident that your students understand the expectations of the task verbs and have learned enough information in the course, then you can start introducing full-length FRQs. I would hold off until at least units 3 or 4, when students start to learn about solutions to problems. At this point, the easiest way to practice throughout the rest of the year is just to include an FRQ on each unit test. If you have access to unit-based FRQs or FRQs that students have not seen before, that's a great option to use. This is helpful because official FRQs from past exams have the answers online. So keep that in mind if you think cheating will become an issue. When incorporating full-length FRQs on exams, it's important to remember that scores will generally be pretty low early in the year, and hopefully get better as the year progresses. Because of this, avoid grading FRQs as a percentage of the full 10 points. Instead, either give a generous curve or make the FRQ bonus points for the multiple choice portion of the test. If you go the bonus point route, students will likely answer a few questions unless you tell them you can only receive bonus points if they make a valid attempt at each part in the FRQ. My fifth tip: focus on solutions. One of the hardest parts about teaching APES is that students often focus heavily on the environmental problems, which can lead to student disengagement and a feeling of hopelessness. To combat this, try to focus more on solutions throughout the course. This will not only keep students optimistic and engaged, but will also help them understand the content better for the exam. An easy way to incorporate solutions into this class is to include time for discussion after a problem is mentioned. Give students time to think about or look up solutions to the problem presented, and let that help drive the class discussion. Another way to focus on solutions throughout the year is by including projects where students have to come up with solutions with their group and teach others about those solutions. This empowers students to be part of the solution and reinforces their understanding of complex issues. For example, students could design a sustainable community, or they can develop an educational campaign on water conservation. By consistently emphasizing solutions, you are not only preparing students for a key aspect of the exam, but you're also fostering a sense of agency and optimism, showing them that environmental challenges, while significant, are not insurmountable. There are many resources you can use throughout the year to support both your teaching and your students' learning. Your main resource is the College Board website. Here you'll find detailed information about the exam, past FRQs with scoring guidelines and commentary, and the CED. Again, the CED is very important to look through before planning your school year because it includes all the topics you will need to cover in each unit, including the objectives within each topic. It is also helpful to connect with other APES teachers. If you are the only APES teacher in your school or even district, you can connect to others by joining a Facebook group for APES teachers, like National APES Teachers. These groups are great to ask questions, gain resources, and share ideas and best practices. And of course, there are many online platforms that are great resources for you and your students. Because the APES exam is a digital test, using an online platform to give your students the opportunity to mirror the digital testing environment is crucial. College Board's AP Classroom is one of those online platforms and includes daily videos, progress checks, and practice questions in AP Classroom. Another online platform that offers digital testing is UWorld, which offers a full course of videos, practice questions with detailed explanations, a study guide, and a curriculum for teachers. These resources will provide you with the tools and community support you need to thrive this year. The task of preparing students for the AP exam might seem daunting, but by understanding the exam specifics, strategically incorporating hands-on activities, fostering discussion, utilizing case studies, and practicing FRQs effectively, you will equip your students with the knowledge and skills they need to succeed. Remember to always focus on solutions, empowering your students to be agents of positive change. You are not alone in this endeavor. The resources available through College Board, UWorld, and the supportive APES community are there to guide you. Embrace the enthusiasm that brought you to this role and get ready to cultivate a generation of environmentally conscious and scientifically literate citizens. You're going to have a fantastic year. If you want to learn more about how UWorld can help save time and boost student success, visit collegereadiness.uworld.com to access UWorld's library of content you can use in your classroom today.